All right, so happy Monday. So last week we talked about corresponding angles, talked about vertical angles, we talked about linear pairs. If you don't remember any of those words, you need to go back and probably review what we talked about on Friday. I know everybody's at like a different spot, but I need us all to get to the same spot soon. Okay, so if you're behind, you need to catch up. Okay, so if this is 40 degrees, then X would be what? It would also be 40 degrees. And the reason why is because it's in this top right-hand corner. And so these are corresponding. Okay, so they must be congruent. So that means that they are equal. Okay. On figure 2, this is in the bottom left-hand corner. So if I just like pick this up and translate it down here to this spot, because that's essentially what we're doing. We're taking this entire thing and just moving it down. It's in the bottom left-hand corner. So these are opposite of each other, which means that they're vertical angles. These are vertical angles, which means that this is also 61 degrees. Okay, so notice how I'm using the vocab to determine what the angle measurement is. Okay, this is in the bottom right-hand corner, so I'm going to just translate it down here at the bottom. So this is 98, and this line creates 180 degrees. Then 180 minus 98, 180 minus 98 is going to give me 82. This is going to be 82 degrees. Okay. Take a second, try number 4. Okay. So I'm going to translate this down here. And since they are vertical angles, X is going to equal 125. Okay. So normally these are going to be either equal or you're going to subtract it from 180 and then solve for the angle. Okay. It's probably one of those two things in these scenarios. Okay. So today we're going to prove corresponding angles are congruent and prove alternate interior angles are congruent. So again, there's going to be a lot of vocab that's thrown out at you. Hopefully you got that vocab sheet from the sub. If you didn't, see if they have any more. I'm going to make sure you hang on to it because you only get one sheet. All right, so prove the angle relationship below using rigid motion. So remember, rigid motion is what we learned in the first unit. We're going to zoom out to use the orange tracing stencil on each slide to experiment with the rigid motion. Answer the questions using GeoGebra applets to get a hint to confirm your findings, and then write a paragraph proof to explain your reasoning. So let's talk about what a proof is. A proof is some kind of like paragraph looking, statement looking thing that tells us why something is the way that it is. It's kind of like when you ask your mom, why does this happen? And she said, because I said so. Well, that wouldn't classify as a proof. It would have to be like steps to why something happened. Okay, so we're going to walk through this together. Okay, so corresponding angles. If I can get this to work. Hang on once. All right, so for some reason that one link wasn't working. So I'll drop the new one in there in just a second. But we're going to start with this corresponding angles. All right, so, okay. So you're going to make a copy of this, and this is actually what you're going to submit today. Okay, so tracing stencil. All right, so in the image below, lines AE and FH are parallel and intersected by the transversal ID. Okay, so we see ID is right here. Okay. Prove using rigid motion that AMB is congruent to FGI. Okay, so zoom out using the using the rigid motion. Okay, so we see how we took the black one and the orange one is the line, but we've done like a transformation to it. So what have we done? Well, you see how this I is down here at the bottom, and then now I is at the top. So what rigid transformation did we do? Well, we did 180-degree rotation. 180-degree rotation. So does this rigid motion work for other sets of corresponding angles? So what I mean by this is this angle down here is the same thing as the angle that's down here. And the reason why we can prove it is if we flip the 180 degrees, okay, then it should be the same. Okay, so let me see if I can actually show you how this works. Let me see if I can put this in the slideshow. Okay. That's fine. All right. Let's use the GeoGebra applet to confirm our thinking. Okay, so in the applet, transversal intersects two parallel lines. When this happens, there are four corresponding angles that are formed. Okay, and we can see that. All right, now we take this and slide it up. That's a translation, right? Okay. Now if we take it and we rotate it, let's try that again. Let's start over. That's the too many things. There you go. All right. So this is moving it. So this is translating it. Okay. This is rotating it. And this is kind of like reflecting it, but kind of not. This is just kind of moving the angle. Okay. So I wish I could show you all of those pairs all at the same time. Coming back in here. How do we show that A and B, angle A and B, the mess of lines, is the same thing as FGI and A and B. A. That's a mess. So here would be an example of the paragraph proof. So vertical angles are congruent. That's what we're trying to prove. So if we rotated the figure 180 degrees around the point E, so if we flip this guy, then EA goes to EB and ED goes to EC. That means that the rotation takes AED onto BEC. So AED is equal to BEC. That's what it's saying. Okay. And I would maybe write that one now. Okay. Let's talk about alternate interior angles. Okay, what rigid motion can map EBM, probably should do this one. EBM to FGM. This guy. Okay, now remember, alternate interior are inside, okay, and across the transversal. Okay, so what happened from here to here? From here to here. Well, let's look at our like little GeoGebra output. Actually, let's use EBM to FGM. How can we transform from this to this? Well, we could probably rotate it, right? We could rotate it 180 degrees. We could do that. Okay. It kind of looks like this translated. It moved all the way out here. Oh, I can actually move this guy. It won't let me because it's not a copy. Sorry. Okay. So let's go ahead and look at the sample proof. Okay, so the sample proof on here, it says that we could rotate it 180 degrees. Okay. And since, oh, this is for vertical angles, sorry. So if we did rotate it 180 degrees, let's see what would happen. Rotate it 180 degrees, and we want to go from EBM, and we rotated it, we would get FGM. Let's actually try that one. Give me 1 second. All right, so finally it'll let me move it. Okay, so if I took the orange line, and it's the exact same thing as the black line, but if we took that and we rotated it 180 degrees. FGM is now all the way up here. Okay, so that's not, is it the same thing as what we wanted? EBM? Yes. Okay, so those are alternate ulterior once we rotate it 180 degrees. Okay, so again, we're writing out a paragraph explaining our reasoning in words. So notice how what we did in the original, the sample proof, since we rotated 180 degrees, then you would write, then EA goes to EB and ED goes to EC. So that angle, going back to our original, angle EBM goes to FGM, which means that they are congruent by alternate interior angles. I know it's a lot. Okay, last one. Okay, we got alternate exterior angles. We want to go from ABD, so it's top, high, and right, to HGI. So we're going to take this stencil. Okay, let's see if we rotated it, if that would get us to it. With this bottom right-hand corner one. And that's exactly what would happen. So if we rotated it 180 degrees, and this is what you would be typing out, if we rotated 180 degrees, then AE, and you would write the next part, coming here, AE goes to BE, and ED goes to EC. So that when we come back over here, we would have ABD map to HGI, which means that those alternate exterior angles are congruent. So again, we're using that rigid motion in order to prove that those two angles are congruent. So all I need you to know is that alternate exterior angles are also congruent. Okay. All right. Going back to the original PowerPoint. Okay. All right, so to brief the exploration and verify all students understand that rigid motions used to determine the angles of congruence. Okay, so again, what we did was we said, all right, we take 180 degrees, we rotate it, and we can prove alternate exterior angles are congruent, alternate interior angles are congruent, and I don't remember the last one. Corresponding angles are congruent. Okay, so I want you to write those out. Okay. Now, again, write me a summary of what you learned. Okay. I would definitely know my my vocab very well for this unit. That's how you're going to be successful. Okay. Just kind of a recap. If I have a transversal, cut two parallel lines, this is the transversal. Okay, so if I have this position right here, it's the same thing as playing this position right here. I kind of think of these as like football or basketball or volleyball. if I play quarterback on this team, I'm going to play quarterback on this team as well, right? In that same position. I'm not going to go be an offensive lineman if I've always played quarterback. Okay. These angles are vertical angles, and you can do that with all of these. There's multiple vertical angles. Anything that's like cross, I think of the V that's right here to remind me vertical angles. Okay. I also have alternate interior angles. Okay, so interior is going to be inside these two parallel lines, and it's always going to be across the transversal. So this is alternate interior angles. Alternate exterior angles is going to be outside of the two parallel lines. So it would be something like this one and this one. Those are alternate exterior angles. Now there's a couple other ones that we're going to talk about, but those are going to come up over the next couple of days. So again, hang on to that sheet and make sure that you can understand those vocab words.